to a ham up in Northern California. Took him 5 years to find one. We finally found one, and our friend Andy W6WUH kindly gave it to this gentleman to help him out after his 5-year search for unobtainium. So it turns out that there was a second receiver. It's a receiver power supply transmitter set, and you can look it up on the internet, SSTR-1, and it happened to be a second receiver, a spare receiver, and so that was sent to me to be overhauled, repaired, overhauled, and we'll fabricate up a power plug for it, because that was a difficult thing to find. And so he sent me the radio double boxed and manual, even with descriptions of the power plug. And I don't know if I don't have it right here on the bench, but I found a what is that thing? I found a female, and then I found that I had 6-pin versions of this, the same pin, a male and a female, but with a 6th pin in the center, but all the rest is the same. So I'm going to be able to fabricate him some plugs, and we'll try to overhaul this radio. A big learning experience. This is a once-in-a-lifetime thing to even see one of these radios. This is something you might find in a museum in Europe, but this is a very difficult thing to find. I'll turn this thing off. I got nothing to say for a minute. Well, this is Larry in California, W6WUH. Ordinarily, I regard box opening videos as something that's done by pimply kids and internet shills trying to sell something. But nothing is being sold here. But what we got in the box here is a very rare World War II spy radio receiver, the SSTR-1. This belongs. So anyway, you get to share the whole experience here with me, because when are we ever going to get to see one of these ever again? I have no idea. I didn't think in my lifetime I would ever see one. There's quite a number of different spy radios, and this is among the rarest of them. I had frankly never heard of this until my friend Lee started getting on the SwapNet and asking for one. And so there you go. Now, military radios are not my thing, and I'm sure there's other people who know far more about this than I do. But there it is, a beautiful little superhet. Thing is gorgeous. SSR-1G. Got a serial number on it. Tuning works. Switches work. All pretty smooth and pretty nice. He mentioned that he thought there was a little data plate that went on the bottom that isn't here. The panel is gorgeous. The outer case is kind of rough, but I'm not here to do cosmetic work. My job is to make it go, Daddy. So there we are. I'm going to have to figure out how to get this out of the case now. There we go. Gravity. So there's the unit. It uses Lochtel tubes. can see 1, 2, 3, 4, 5 loctile tubes. It's a superhet. Been hammered on a little bit. And let's see, it's what do you call it? Got the anti-fungal varnish on everything. Looks all original. There's a little tiny glow bar resistor in here. We'll have to figure out why they needed that. Somebody soldered on there. Here's a screw base lamp, like a number 47, only screw base, with a little shield, and that directs the light over to the tuning dial. Here's a Japanese capacitor in here. Somebody has put in, and I would say offhand that Japanese capacitor could be 40 or 50 years old itself. And I don't know whether this looks like coils underneath this little terminal board. Not much in the way of capacitors in the thing that are obviously visible. Here's a couple of micas. I got a feeling sure what we're going to find. This may be a 3 or 4 section capacitor right here. I think that's what it is. Got to read the schematic on it. Will enlighten me some more. Here's the schematic here. I don't know if you can read this or not. I'll get the camera and zoom in on that thing. Probably take a still shot of it. Get it in the video here. Flashlight or something to make that. I think that's going to be kind of hard to see, but anyway, here there's a pictorial diagram showing you the tube layout and the tuning slugs are all labeled, and then we've got schematic. I'll just look at this real quick. It looks like it's a mixer directly to the antenna. Oscillator, couple of stages of IF, detector, and audio. That's what it looks like. So all right. Well, we'll analyze it better, and then we'll talk about it. No point in trying to guess now. But anyway, there's the first look at the SSTR-1 receiver, and I'll study the schematic and learn the location of everything, and then we'll talk about how it works. It's a heavy little sucker. This is a very dense and compact little receiver. Everything is steel, and pretty nice. Split gear anti-backlash drive. I'm really surprised to see that, but you got to realize that it's a CW receiver, and it has to be stable, and really very beautiful. Split gear drive, ball bearing tuning capacitor. Lovely little thing. Very, very nice. So, and it uses Lochtel tubes, which are very, very rugged tubes. So just really the perfect application for portable and mobile radios. Is just exactly what they're designed for. Okay, that's all I've got to say at the moment. This is the underside of the World War II spy radio, the SSR-1. And what we're doing is replacing all the capacitors. This is an extremely rare radio, so it's got to work on a lot of the documentation before you can begin the process. So let me just show you the general location of capacitors. They basically are numbered from left to right with a couple of exceptions. Let's show you on here that C1 goes right here. It's removed at the moment. C2 is this electrolytic capacitor. C3 and C4 are underneath this board. C6, I'm not quite sure where, here's C6. C7 and C10 are down at the end. They're 600 volt capacitors. All the rest are 400 volt. And 5, 6, 7, 8 are under here. This is 8. This is a 0.25 at 150. That's a cathode bypass cap for the detector. And all the rest are tubular, and they're under there, except for this one, which was an electrolytic. So here's the list. Get the light on it so you can see it properly. Let's get it up here. Here's the list. C1, 3, 4, 5, 6, and 9 are 0.047 at 400. There's 1 8 microfarad at 450 electrolytic, and there's 2 each 0.01s at 600, and then that 1 paper capacitor, the 0.25 at 25 volts. So here's the capacitors we're going to use. These are the 600 volt ones. These are the 400 volt ones. One of these 0.047s is supposed to be 600 volts, and I didn't have one, so I'm going to use a 1000 volt unit. But that's it. Here's the electrolytic that goes in here, and pretty straightforward. So what you have to do, though, because there's no documentation, go through and locate all the capacitors on the schematic, and then photograph the thing and physically find out where they are. Most of them are hidden under these boards, and so you have to figure out what the tube element they're supposed to be connected to, and work backwards to figure out where they're located, so that you can figure out what capacitor they actually are. And I've just arbitrarily numbered them here, starting at the input side and going to the audio output at the other side, which is a pretty typical thing to do. So that's where we're at right now. I'm just getting ready to replace these capacitors. Okay, here we have several capacitors replaced. C6, C9, C7, C10, and they're all in there in such a way that the leads won't short out. positioned the same way they were. So doing pretty good. We measured all of the capacitors that came out, and all the ones that are supposed to be 0.45 were over 0.6. So we replaced them with ones that are 0.047. And the Q and the dissipation and the series resistance are quite a bit better on the new ones. So we had a dissipation of 0.018 and a Q of 55 and a series resistance of 15 ohms with one of the ones that came out, and dissipation of 0.0002 instead of 0.018. That's quite an improvement. A Q of 6,000 instead of a Q of 55, and a electrical series resistance of 0.28 ohms instead of 15 ohms. So there's quite a bit improvement in quality of those capacitors, and that's pretty typical throughout. So next will be to replace these two underneath, this electrolytic, and there's another one that goes across here. And then this one measures okay, but it's, so maybe we'll try that and order something, get the exact value if we can. But I think a close value, a lot of these things are you know, minus 20 and plus 40%, so the values are often not that critical. Anyway, I think having one that's not a dead short will be a big improvement, even if the value's not exactly right. Okay, W6WUH, Larry in California. So we've finished recapping the very rare SSTR-1 receiver. And so I'll just show you what's happened. We lifted up this board here. We had to take off a few wires here so we could lift this up and replace the capacitors that are underneath. The capacitors that are under this board just slid out in this direction. This capacitor was taken out, and they just undo the leads and pull them out this way and fish them back in and solder them up. You can sort of see the leads coming up from under the board. We had to make this up out of a couple of capacitors. We had to get the right value and the right voltage rating, and this one fit right in here. And this paper capacitor was a 0.25 at 150, and I didn't have a cathode bypass cap like that, so we were able to put together two in series to get the right value, and a couple of 0.47s in series, so we got half the value, and the voltage rating is way higher than it needs to be. It all fits in here, looks pretty sanitary, and I think the wiring is nicely done. We've got the glow bar resistor reconnected here. It was disconnected from the circuit. I don't know why. Maybe its value isn't right, but hard to know because they have to be hot. So we'll see. Going to put the tubes in it now and hook it up to the power supply temporarily. And I think we'll apply the right voltage here, so the glow bar resistor doesn't really have to be in the circuit to work. put the new Loctile tubes in it, and hook up a pair of earphones and an antenna or a signal generator, and see what we get. Hopefully we'll get no smoke coming out of it, and we can get a signal through it. Then we can do the alignment and calibration procedures, pick up antenna on the RF and the oscillator, get it calibrated right, and if that's all working, align the IF, of course, and that's all working, then we'll just run it on the bench for a day or two to make sure that it's reliable, and then we'll send it back. If we don't encounter other problems, there's a bunch of mica capacitors in this thing, including some in here, and oops, bunch under the in here, underneath the board and on top as well. So there's always a possibility that one of those micas can be bad, but in general you don't expect to encounter that. The voltages in this receiver are very low, a couple of hundred volts at the most, and you've got 400 volts coming into it, but it's got that glow bar dropping resistor to tame it down, and that simplified the power supply. This was all stuff that that anti-Nazi agents in France or the Denmark, the Netherlands, Norway would use, and they'd hide it in their clothing and hide it in a loaf of bread. And there's a power supply and a transmitter and this receiver. So it was quite a bit of hardware to hide, and you got killed if you got caught with it. So that's that. Well, unfortunately, my camera viewfinder is broken, so I can't see what I'm photographing here. But we did get grommet and the cable installed in the radio, and wired up at the ground, the filament, the B plus, and the antenna. And we did get the radio working yesterday. Everything works, but there's two tube sockets where Loctile pins have been put in bent and jammed in the socket, and they've mangled the pins. And this particular pin right here may actually be broken. I'm going to have to extract the pin from the socket and inspect it, try to get it back in shape and put it back in the socket. The other ones, we've been able to take a dental pick and get them bent back into shape, and so we'll have to tweak them so that they're a nice tight fit. But when you put the tubes in here, instead of, these are Loctile tubes and they're supposed to snap in place and be pretty rugged, and this one and this one, the RF amplifier and the BFO just were loose in the socket, and you had to hold them a certain way in order to make the radio work at all. Not acceptable. So that's what we're working on now. But everything did work. The calibration was reasonably close. Sensitivity was okay. So once we get these tube pins fixed up so that the tubes are secure in the sockets, we'll be able to go do a calibration and the peaking and alignment, and we'll be done. So we've had to disconnect the ground wires from this tube pin so that we can extract it from the socket and work on it and put it back in. These tube sockets are riveted in, and I don't even know if I have any Loctile tube sockets, let alone the right kind to salvage a pin out of. So we're going to have to try to repair what we got. Well, I don't know if this is in focus or not, but there's the tube contact, and there's a tube pin, and you can see that it's just as sloppy as hell. So somehow I've got to make this thing work. It's supposed to have 3 fingers in there that make contact with that pin, and there's only 2 now. There's a little tit that sticks out there, and that's what holds the pin in the socket. So I had to make sure that thing was sticking out, so when I jam it through there, it'll lock in. Okay, the idea is to get this thing flat, smooth, no lumps of solder, as little wavy metal as you can, so it'll go through the hole, get the little tit there sticking out so that it'll lock against the backside of the tube socket and lock the tube pin in place. Okay, the tube pin goes in like this, and there's a straight slot on the bottom of the socket, and the bottom of it has to poke right through there and click into place.